people movements consultancy and an analytics company with more than 12 years of experience in the sector. Yes. Every time events, transport systems, cities, the world are getting more and more crowded, so we need to manage how people are moving in a smarter way in order to keep enjoying it, and that's what we are doing. Movement strategies have been worked in most of the major events and locations during the last few years, like Glastonbury or London Olympics. We have also worked in Shanghai Expo 2010 or Twickenham and many more. But we don't only analyze movements of people at this small scale, because we also analyze movements at larger scale, like city scale or even country scale. And this is what I'm going to show you now. I'm going to talk about two different projects. The first one is CitySpire, which is a project that we have just started, and we are doing it in a conjunction with 5 other companies. And we are analyzing real-time data for improving the mobility in Manchester area. Because at the moment we have a problem with transport, the public transport system, because it's quite good if you want to go to the city center or to go from the center of one city to the center of a neighbor city. But when it comes to go from one suburb to another suburb or to make orbital journeys, then public transport is not that good, so we end up using our own cars. And by using the car, we are polluting the cities get more congested with all the problems associated with that. So we are proposing a solution which is an on-demand, real-time, shared local public transport system. So this is a very flexible, convenient, and accessible tool for the user, because they can manage it from the phone, they can request the lift, and it's also very good for the city, because the city is getting less congested, less polluted, and they can integrate the system in the existing transport system model, so it's convenient for both parts. But in order to be able to deliver this solution, we have to analyze data. Loads of data, like real-time data, historical data, mobility patterns, and so on. So we are analyzing Wi-Fi, GPS, and Bluetooth data, so we are feeding the system with it in order to keep it running. But we are not only using the data to improve this transport system, but also we use it to create like real-time incentives for the users, so we can promote more sustainable modes of transport, like this one, or we can give the users discounts, like, okay, you will get a free coffee when you get to your destination, or another discount if you are traveling in this system the next time, something like that. So at the end, the user gets a better experience, and also the city, because we are promoting and encouraging people to use this system. Using this information about sociodemographics, mobility patterns, attitudes, and so on, we can use this data in the retail sector, because retailers, they can use these profilings of people in order to adapt the offer to the customers, or they can send personalized offers to the customers. So it's a win-win situation for both the customer and the retailers, because they will increase their revenue and you will get what you are really interested in at a better value. And also, another part of the solution is to be used in events like, let's say, a concert in the O2. For example, if you are with your phone, then you are connected to the Wi-Fi data or the Bluetooth, so we know in real time where about in the event people are, so we know how crowded an area is in comparison to another area. We can compare the volumes, the actual volumes, with the historical or the average volumes for similar days before, or you know how busy a queue is, so you can go to a less busy queue, or how crowded the bars are. So at the end, you will get that information in your phone. So you will take smarter decisions and wiser decisions, so you will enjoy your stay there in the venue much more, because you are not wasting your time just queuing there. And it's also quite good for the organizers of the event, because knowing where people are or where the real demand is, they can move the staff or the resources to that particular area, So at the end, the event is also managed in a more efficient way. So as I said, this is a project that we are doing with these other companies. It's a 18-month project that we have just started, so it will finish by the end of next year. And it's been funded by Innovative UK, which is a public body for innovation in the United Kingdom. The second project I'm going to talk about is Transport Information System. And this is a project that we have done with Telefónica. Telefónica is the owner of O2, so we are analyzing mobile phone data. And we have been working with them for the last 4 years or so we have a strong relationship with many projects done. So the first thing is, I'm going to show you what is mobile phone data, or how can it be used in transport. So every time you use your phone, you make a call, you receive a text, or you browse the internet, you are making connections to the cell towers. So you are creating events to the cell you are connected when you are connected. And you can also create passive events. So every now and then, the phone needs to update itself, so it sends a connection to the cell, so you will get another event. Or also, when you are moving and you are changing from one group of cells to another group of cells, you will get a connection in those boundary of cells. And this data is recorded 24/7 and every single day, so at the end we are dealing with billions of events, so it's quite a large data set. I know it can sound a little bit scary, like somebody is tracking me or they know where I am, but not at all, because everything is anonymized. We cannot track individuals. In fact, we are not interested in individuals at all. We are interested in how the crowd are moving. And we are fulfilling with all the regulation regarding privacy issues, so there is nothing to worry about. So let's see this example here where we have a user going from the left-hand side of the image to the right-hand side of the image, and this user is not actively using the phone. So they are only creating passive events. The hexagons represent the cells, and the different colors are the different aggregations of cells that I said before, so the location areas. So this user is going to make an event every time he's crossing one of those aggregations of cells. But we can also have this other situation where another user is actively using the phone. So apart from the passive events in black, they are generating those active events. So at the end, we end up with a more detailed data and more reliable. But what does the data mean, those events? Because in order to be able to get some insight from it, we have to transform the events in dwells and journeys. So let's say that you are staying here, you are going to be connected in a bunch of different cells around this point, so you know that, or we know that you are stationary in one place, so that's a dwell. But on the contrary, if you are moving from one place to another, you are going to be connected to a bunch of different cells, and those cells are far from each other, so we can assume that you are making a journey. So at the end of the day, we end up with a kind of network where the nodes are the dwells where you are staying, and then the connections are the journeys. So we can have a user starting the day in A, then user is going to D, then going to C, then is coming back to D, and so on. And this information of dwells and journeys can be enriched quite a lot, because when you sign up a contract, for example, you give your details of age and gender, so we can collect that data. Also, depending on the cells you are connected during your journey, we can determine whether that journey is a road or rail or air journey, because we can also measure the time that it takes to go from one cell to another cell, so knowing the distance, we know the speed. And we can also classify the dwells in order to get the journey purpose, because, for example, if you are dwelling most of the nights in the same place, we can assume that the place is your home location, or if you are dwelling during the day in one specific area, that's your working area. So using that, we can classify if a journey is going from home to work, work to wherever, or wherever to home, so on. And on top of that, we can also get the journey frequency and journey route depending on the cells that the user is connected during the journey. And now I'm going to show you a real project. Yeah, the real project itself is the Transport Information System, which we did for Highways England. Highways England is the public body in charge of maintaining and managing the motorways and A roads in England. And they have to invest a lot of money in order to keep the motorways running and in good conditions. But they need to invest that money wisely, because they cannot spend tons of money in things that are not needed. So in order to know where to spend the money, they need to know how people are moving from where to where, how often, the volumes of people moving, and so on. And that's what we are giving them. Because let's imagine a situation here where we have, in town B, there is always a problem with the traffic, because traffic is stuck every morning, so it's very crowded, and Highways England needs to solve that issue. But in order to apply the correct solution, they need to know what is causing that problem. Because it can be people going from B to C, so in that case, maybe you can add some lines in some of the avenues or change the direction of some of the streets in the town, or maybe it's people going from A to B or from C to B, or who knows. It can also be people going from A to C, and in that case, you will have to build a complete new bypass. So it means that those decisions, they can be quite, the result of applying one solution or another can be quite expensive. So you need to know what is causing the problem in order to take the right decision. So to get that data, we built this application, or this web service for Highways England. So we built it from scratch, because before the use of mobile phone data in transport projects, they were collecting the data using roadside interviews mainly. So this is literally stopping people on the roadside and asking them where they are going. So as you can imagine, it's quite disturbing, and the sample you get is not very big, and then it takes quite a lot of time to get the data, and it's quite expensive. So with mobile phone data, you don't have all those problems, because it's faster and sample is far bigger, and you also get additional information. So with this application, an employee from Highways England, for example, they can just upload the project. Then once the project is authorized, they can select the zoning system they are going to use, because in this project we are using MSOAs, an aggregation of MSOAs. I don't know if you know MSOAs, but they are like a statistical division of the United Kingdom, with at least 7,000 people living in each of them. So these are the areas we are using. And we can upload here a shapefile or just a CSV, and at the end, they can visualize the zoning system they have uploaded. So in general, the closer you are to the area of interest, the smaller the zones, and the farther away you are, the bigger the zones. So you can see there, and this is the cordon area, the area of interest, where zones are quite small. So once you are happy with it, then you submit the zoning system, and you can start extracting the data. So the first thing is to select the dates you are interested in. You can include or you can exclude weekends or bank holidays, because mobility is very different in those days, so it depends on the project. And you can select the days that you want. But we are not giving them values for each of the individual days. We are giving average values, because otherwise it's more statistically robust to give average for all the days, and also for privacy issues. The user can also segment the data by time of the day. So they can choose many different time periods. They can segment the data by hour or by groups of hour, because again, it's not the same, the volumes of people during AM peak time or during the evening. And finally, they can select the mode of transport they are interested in. In this case, as this is Highways England, we are selecting road and also train, but not journeys. And they can also choose the trip purposes they are interested in, the ones I said before, like home to work, work to home, work to wherever, whatever to wherever, and so on. So it depends on the project and what they want. So at the end, automatically they get the data they want, which is a bunch of boring CSV, but it's what they need. So in these CSVs, they have the start location, end location, and then the number of trips in each of those trip purposes. And they are also getting a different CSV file for each of the time periods they selected before. So thank you very much for attending the presentation, and if you want to contact us or you want more details, please feel free to send us an email or visit our stand there. Thank you.